Good evening, everyone. Welcome to the virtual Second Saturday Stars program for May of 2021. My name is Roger Moore. We have, as we've done in the past, we have three brief presentations for you. Sometimes it's difficult to come up with just three topics. There's so much exciting going on in astronomy and space, but we'll start off with, I'll do a little overview of what's up in the night sky for May. Then I'll turn it over to Bill, who will give us some Martian news. And then finally, Mark will end it up with information on the progress of the Artemis program. We will have a question and answer period at the end, although during the program, feel free to post comments and questions on the chat functions of either Facebook or YouTube. So May night sky. May is a great time to be outside at night. The temperatures are mild, the humidity is low, and there's always something interesting to see. What I'm going to use to show you what's up in the sky is a program called Stellarium. This is a free download. You can install it on your computer. It's just a wonderful planetarium program. And this is the website, stellarium.org. So during May, we have a new moon on May 11th, and that's when our skies tend to be the darkest because the moon is between us and the sun. You will have several opportunities to view the three inner rocky planets mid-May. We have a full moon on May 26th, another supermoon. So as you probably know, the moon orbits the Earth in an elliptical orbit, and so sometimes it's closer to us and sometimes it's farther away. If we happen to have a full moon when it is closer to us, they call that a supermoon because it's a little bit larger in the sky. It appears a little bit larger in the sky, although most people wouldn't be aware of the difference. There will be a lunar eclipse best visible on the west coast on the 26th. That's the only time you can have a lunar eclipse during a full moon. Although for us, it'll be kind of a non-event. We will have a partial penumbral lunar eclipse early in the morning on May 26th, low in the southwest. And I'll go over what that means in just a couple minutes. So if you go outside, bring your binoculars with you. I've got a couple of things you might be interested in looking at, but this is looking south, a little bit south-southwest. And the predominant constellation is pretty easy to see is this one here in the center. That's Leo. Also last month when Mark told us about galaxies, some of the galaxies he mentioned are in this area of the sky around Leo. The brightest stars include Arteris, Spica, the two heads of Gemini, Castor and Pollux. There's Procyon, and down at the horizon is Sirius, the dog star from Canis Major. And then Mars is still up in the sky. You might be able to pick that out by its color. And then the brightest star in Leo, which is Regulus. So Regulus is the bottom of what's called the sickle of Leo. It's this little backwards question mark, part of the constellation. And when it's drawn out, you usually see the rest of the body drawn out that way. So that is Leo. So this is the time to pick up your binoculars. And if you imagine a line between Regulus and Pollux, kind of draw an imaginary line, and take your binoculars and scan along that line so you get about midway between the two of them, not quite halfway between Regulus and Pollux. And you should be able to find what's called the Beehive Cluster, or M44. It's the 44th object that was cataloged by Charles Messier in the late 1700s. So the Beehive Cluster, it's just a pretty star cluster. It's a group of stars that were all formed about the same time. They're all traveling through space together. And this cluster happens to be about 575 light years away. So that means the light that's coming to us took 575 years to get here. But it's a pretty sight, even in binoculars. If you turn around and face the north, you'll see the star grouping that most everyone can recognize the Big Dipper, which is part of Ursa Major. The bright stars to the north at this time of year are Capella and Polaris, of course, and Vega. Vega is interesting because Vega will be almost straight overhead sometime during the summer. But Polaris is easy to find, as we pointed out before. You just use the pointer stars for the Big Dipper. But right now, I'd like you to look at the bend of the handle of the Big Dipper, and that star is called Mizar. If you have really good vision, you might be able to pick out that there's actually two stars there. But if you can't quite do that, take your binoculars again and look at Mizar, and you'll see that there's two stars there. Mizar is the brighter one. Alcor is the dimmer one. If you have a small telescope, you might want to look at Mizar through the telescope, because then you'll discover that Mizar is actually a double star. There's two stars at Mizar, one at Alcor. This is just a background star. It's not part of this grouping. So what we thought was one star at first, we now see as three. Interesting, though, astronomers have since discovered that each one of those three stars has a companion star. There's actually a total of 6 stars there. And they think they're all gravitationally bound. They're bound by gravity, orbiting around a common center of gravity. Moving later in the month, around May 17th or so, shortly after sunset, you can pick out the 3 inner rocky planets, actually 4 if you count the one that's on the horizon here, which is us, and the moon will be up at May 17th. If you want to use your binoculars to pick out these planets, that'd be great, but just be careful, wait till the sun is below the horizon. You don't want to look at the sun through your binoculars. And later in the month, those 3 planets will still be there, getting a little bit lower to the horizon. So you really have to have a clear view to the west to see this. But it's a great opportunity to see the 3 inner planets. And if you're a morning person and you're up before sunrise, this is the view you'll see looking to the east. You can see Jupiter and Saturn. Once again, if you have your binoculars handy, take a look at Jupiter. You might be able to pick out 2 or 3 or 4 of the major moons, the 4 Galilean moons of Jupiter. And as you go later in the month, those 2 planets will get higher in the sky. So the lunar eclipse, the moon has 2 shadows that we label as penumbra and umbra. And in order to see the total eclipse, you have to be somewhere on Earth where the moon passes through the umbra, the darker shadow. For us, though, the moon is going to pass through just the edge of the penumbra. So it's just going to be a partial penumbral eclipse. This is a map of where you can see the eclipse best. The darker areas is where you'll see the total eclipse, and that's, of course, over the Pacific. Western US will get to see a good part of it, but you see as you get further east, there's less and less of the eclipse visible, and the cutoff point is right near us. So what we will see is just a partial penumbral eclipse early in the morning of the 26th. And this is a little fuzzy, but you might notice the altitude of the moon is less than a degree high. So it's going to be very low in the southwest. So just so that you're aware, there is an eclipse that day, but we won't see very much from our location. And now I will turn this over to Bill, and he can tell us about the news from Mars.
Thank you, Roger. Let's hope that the weather holds, because like you said, May is a great time to catch the night sky. Okay. Good evening. My name is Bill Cloutier, and tonight we're going to check in with the Mars News Network, covering one of the coolest places in the solar system, the Red Planet. We're going to start off with a little traffic and weather. There are currently 8 spacecraft operating around Mars. The oldest one being the 2001 Mars Odyssey that arrived in late 2001. And the most recent spacecraft, which include United Arab Emirates Hope probe and the Chinese probe that both arrived in February of this year. On the ground, traffic's a little lighter, but no less interesting. We have 2 rovers and 1 helicopter, all very active on the surface at the moment. Now, we monitor the weather on Mars from orbit and also from the ground. So both rovers are equipped with weather stations. And this happens to be a weather report from Jezero Crater. As you can see, it's springtime on Mars, but the daytime temperatures climb to an almost balmy 0 degrees, not quite. That'll improve a little bit as the summer season arrives. But you can see without a thick atmosphere to retain the daytime heat, temperatures at night plunge well below 0. So you can go online and you can follow the weather from day to day on the Mars 2020 Perseverance rover website. So our top story, if you haven't heard, is first flight. On April 19th, a little helicopter that was carried to Mars on the Perseverance rover did a small hop, but really a giant leap into history as being the first controlled flight on another planet. See if we can get it to take off. Again, the first flight lasted less than 40 seconds, but it proved that we could fly. One thing to remember is that on Earth, the record for flying a helicopter is less than 42,000 feet. And what we did on Mars was equivalent to flying at 100,000 feet. That's the rarefied atmosphere on Mars. So again, small hop, but giant accomplishment. You can see for the first flight, it just went up about 10, 11 feet, and then right back down again. Again, it was just an incremental proof of concept. Ingenuity, which is the name of the helicopter, is equipped with 2 cameras, one color, one black and white, and they're used for navigation. They are imaging the surface as the helicopter moves along, and they're looking for landmarks and comparing them against what they have in their memory. So this is a picture, this is a shadow cast on the surface of Mars by the Ingenuity helicopter. So you can see its twin rotors and its feet that look like little antennas sticking out. So shortly after the first flight was completed very successfully, the NASA administrator announced that they were going to name this particular location where this flight took place the Wright Brothers Field. And that's where the first 5 flights have all started from, the Wright Brothers Field on Mars. Now, Ingenuity has flown 5 times. The last time was yesterday. And each time they kind of pushed the boundary, flying a little further, a little faster, doing more maneuvers, really working on the envelope for the helicopter, testing and probing and seeing how it performed compared to how it was performing in the vacuum chambers on Earth. Now, the last flight, yesterday's flight, was a little bit different because instead of coming back to Wright Brothers Field, it kept going, but I'll get into that in a second. So I mentioned there were 2 cameras. This is a photograph taken by the helicopter, and you can see way off in the left corner, it captured the Perseverance rover. Now, the rover has been monitoring these flights, recording the flights, transmitting information from the helicopter to Earth, and basically keeping an eye on the tests that were going on. The oval at the top center of the screen is the landing spot of the rover. And I know it's hard to make out, but there are two, I'll call them circular sections in that oval where the dust has been scoured away, and they're lighter in color. And that's from the rockets on the descent stage blowing the dust away on either side as it set the rover down. So the rover was so successful that NASA decided to extend its mission. Originally, those 5 flights that you saw would have been the end of it. It was given a 30-day window to conduct those 5 flights, and then that was going to be the end of the test, the end of the demonstration. But the helicopter outperformed all the objectives and has been operating so well that NASA has decided to give it another 30 days and possibly several more months. And there are several factors. I mentioned the performance of the helicopter, but also the rover has found some very interesting targets around the landing area that the scientists want to explore. So instead of the rover driving off to the delta to explore that ancient feature, it's staying very close to the landing area, which will allow it to communicate with the helicopter. So NASA has decided to keep the helicopter active. It's not going to fly as often as it has. It may only fly once every couple of weeks, but they're changing its mission from one of a demonstration to an actual part of the operations. So they're actually going to use the helicopter to scout locations where the rover might, where the rover might drive to. Another first, NASA turned on an experiment on the rover called MOXIE. And MOXIE was designed to demonstrate that you could extract oxygen from the atmosphere of Mars, which is primarily carbon dioxide. So just recently, this experiment was turned on and it actually generated several grams of oxygen. You can see a little graph here. The amount of oxygen generated isn't important as much as the demonstration of concept. If we can do this, if we can pull out oxygen from the Martian atmosphere, we can use it for rocket fuel. We can use it for breathing air, should we decide to colonize Mars. A lot of applications for oxygen. We could even combine it with hydrogen and produce drinking water. So another big step in our exploration of Mars and living off the land. This proof of concept that we can take what's there and use it rather than carrying resources out to Mars. Another interesting bit of news is that researchers have been looking at Martian meteorites. Now, Martian meteorites are pieces of Mars that have been blown off the planet by an impact or some other process and made their way to Earth, falling to Earth, and we find them primarily in the deserts in North Africa and in the ice sheets in Antarctica, where they're easy to see against the sand or the ice. And what they've noticed is that if you take these meteorites and you expose them to a watery environment, something that we believe Mars had several billion years ago, you can get chemical reactions that produce enough energy to support life, very consistent with what we find underground on Earth. So again, it's another piece of the puzzle and maybe it's pointing us where to look on Mars for life if it's there. So someday, and there's a lot of people thinking about this, about traveling to Mars, sending humans to Mars. There's a lot of challenges to doing that. And really the weak link of going to Mars is the human body. We're very delicate creatures. And the challenges of space include radiation and long-term weightlessness. There are physiological changes to the body, psychological changes, being cooped up in a spacecraft for right now 6 to 7 months at best. And then again, you have to bring all life support, food, water, all those things that when we send a robotic spacecraft to Mars, we don't have to worry about. But when we're sending these fragile, soft bodies, we have to take care of them. There's a lot of care and feeding. So there is one consistent factor in all these challenges, and that's time. If we can shorten the time, we can mitigate the effects of radiation, the effects of weightlessness, the amount of life support, the amount of fuel. So time is really where we have to spend our resources and be able to reduce the travel time to Mars. Interestingly enough, this has really gotten the attention of NASA, Department of Energy, the Defense Department, and all these agencies are looking at one common denominator, and that is nuclear power. They're looking at a way to drive spacecraft with nuclear engines, either thermal or electric. And they believe that by doing so, we can cut the travel time by at least a half. And that would be a great savings in a number of areas that I just mentioned. In fact, DARPA just issued contracts to General Atomics for a reactor that can be used on a spacecraft between the moon and the Earth. And they've also issued contracts to Lockheed Martin and Blue Origin to design such a spacecraft. NASA is working on its own contracts for engine development. And I mentioned either thermal, nuclear, or electric propulsion. And they really believe this is going to be the future. We need to get to Mars a lot faster than we're doing right now if we're going to alleviate some of those stresses on the human body. The Defense Department is also interested in vehicles that can respond quickly, whatever the issue may be. And nuclear power seems to be what will fit the bill. If you've been following the Chinese space program, and they've done some pretty remarkable things recently. Back last summer, when we were launching our spacecraft to Mars, China was doing the same. Their orbiter arrived at Mars in February, and since then it's been scouting out areas on Mars to set down its lander and rover. And this week it just named its rover after a mythical god of fire and war. It's a solar powered rover, a little bigger than, say, Opportunity was, but smaller than Perseverance. It has a suite of scientific instruments, including ground penetrating radar. And it'll be set down by a combination of heat shield, parachutes, and rockets. Tentative date is May 17th, but the Chinese are very quiet about their exact plan. So we're just going to have to watch and wait. We believe that they're targeting a plane, a level plane in northern Mars called Utopia Planitia. And just to give you an idea of where Utopia is, it's on the right side of the screen up there. It's in the same region where we landed the Viking 2 spacecraft back in 1976. So stay tuned for that. Be interesting to see if they can pull that off. A few months ago, I gave a presentation and there were some questions. And one of the questions was, had Perseverance taken any images of the night sky? And at that time, it had not. But I've been watching the thousands of images that have come down. And on May 4th, two very interesting images came down of the night sky. Now, the rover is equipped with a weather station, which consists of a number of instruments and a whole suite of sensors. Some of the sensors are on the mast. You can see the wind sensor there. They look like probes that stick out at right angles. Some of the sensors are on the rover's deck, the body, and some are inside. One of the instruments is an all-sky camera. And this is the all-sky camera on the left. And its primary function is to monitor sky conditions, look for clouds, monitor the amount of dust in the atmosphere. And it has other functions, but its primary use is daytime observing. But as I mentioned, on May 4th, I saw two images come down, and you can see them on the right. I animated the two images because I wasn't sure what I was looking at, but you can tell that most of what you're seeing is noise, except for one bright object that seems to be moving along the right side. And of course, that got my curiosity. And Roger mentioned a program called Stellarium. If you've ever taken a course at the observatory, or like our adult ed class, or listened to one of Roger's talks, we use Stellarium a lot to teach about the night sky on the Earth. But you can also use Stellarium to stand on a different planet and look at the sky. And that's what I did. I changed my location from Earth to Mars because I wanted to see what that bright object might be. And you have to play with the location settings in Stellarium. You have to know the latitude and longitude of your rover. And then you have to play with the time because Stellarium doesn't have standard time zones on Mars. So I use an app called Mars Clock to get the precise time at the landing site. But looking at the sky that night that those pictures came down, it was pretty clear that I was seeing the minor moon, Deimos, of Mars going across the sky. So I'm hoping they take more pictures and they calibrate the images a little better, so maybe we can pick out some bright stars. And hopefully in the future, if the Earth is in the sky at night, maybe we can get some images of the Earth. So as you can see, Mars is a happening place. I hope you stay tuned. We'll try to keep you up to date. Thank you and good night from the Red Planet. So I think we're going to move on to Mark, and he's going to give us an overview of the Artemis program.
I sure am. Thanks, Bill. Share my screen here. Okay. Good evening. I am Mark Polanski, and tonight I'll be speaking about NASA's plan to return humans to the moon around 2024 and how the latest SpaceX developments fit within that mission. So back in 2005, the Constellation program was the first clear plan to get us back to the moon and eventually to Mars and beyond. The challenge was to do so by 2020. Here we are in 2021, and obviously that has not yet happened. After 4 years of development, a committee was formed to evaluate the progress and future prospects of human spaceflight in the United States. In late 2009, the Augustine Commission determined that the Constellation program was so far behind schedule, underfunded, and well over budget that meeting any of the stated objectives would not be possible. It was removed from the federal budget in 2010, canceling the program, with the exception of one element, the Orion crew capsule, which was to continue development as a lifeboat or escape vessel for the NASA astronauts aboard the International Space Station. In place of the rest of Constellation, additional funding was provided to invest in private companies with the goal of developing commercially available launch services. The idea was to get NASA out of the Earth orbit launch business and focus more on exploration and science. The exception to this mandate was funding allocated for the development of a new heavy lift rocket to launch astronauts and material beyond Earth orbit. This ended up resulting in the Space Launch System, which I'll talk about more later on. From this new direction, the commercial resupply services and commercial crew programs were started, enabling the development and evolution of a new generation of private rockets, including the Falcon 9 from SpaceX and the Arteris from Northrop Grumman Innovation Systems. As a result, access to Earth orbit became significantly less expensive, allowing cargo and crew to be sent up to the International Space Station for a fraction of the cost of a space shuttle flight or a seat in a Russian Soyuz. While the commercial program started to pay off, another new push to beyond Earth orbit started to take shape. In 2017, the Artemis program launched, with the goal of returning humans to the moon by 2024. But this time, the goal was to establish a more sustainable system for long-term presence at the moon, with commercial and private companies and international partners chipping in. The key to a sustainable presence around the moon is a spacecraft called the Lunar Gateway. It's essentially a space station orbiting the moon, providing a convenient go-between from Earth to the lunar surface. Gateway will house equipment and consumables, along with the human lander system to ferry humans down to the lunar surface and back. There's two core elements of Gateway. The first is the power and propulsion element, which, as the name implies, provides solar power and ion thrusters to maneuver around lunar orbit as the foundation for Gateway. The other module is the habitation and logistics outpost, which provides docking ports for Orion and the human landing system, with capability to support a crew of up to 4 for at least 30 days. There's a bunch of other components that ESA and JAXA are chipping into. We'll cover those another time. The other big component required to get humans back to the moon is, of course, a rocket. Not just any rocket, a beast of a rocket. The Space Launch System, or SLS, is a beast in many different ways. It's been in development for about 10 years, carrying with it a cost of about $18.6 billion from 2011 to 2020. The estimated cost for the first few launches will end up being between $1 and $2 billion per launch. For comparison, the space shuttle cost about $500 million per launch by the time it retired in 2011. Of course, the shuttle was in service for many years, so the development costs were spread out over many launches. The cost per launch of SLS is also expected to drop over time in a similar way, assuming funding is provided for continued launches. Justification becomes more difficult to keep funding SLS as commercial rockets develop more capabilities for significantly less cost. For example, a SpaceX Falcon Heavy launch has about 2/3 the payload capacity of SLS. It only costs about $70 million to launch, which is less than 1/10 of the cost of a single SLS launch. Blue Origin's New Glenn rocket will also be significantly less expensive for an equivalent payload capacity. SLS can haul about 95 tons to low Earth orbit and about 26 tons to lunar orbit. There were a number of congressional mandates as part of the SLS development. The premise was to save the jobs of contractors who were working on space shuttle components after the space shuttle was retired by reusing as many parts as possible. The solid rocket booster casings are repurposed from shuttle, along with the RS-25 space shuttle main engines. As of right now, SLS is the only rocket cleared to launch humans to the moon on the Orion spacecraft, as mandated by the Artemis program. Because of the absurdly high cost, the primary use of SLS will be crew transport to Gateway via the Orion capsule. SLS itself is a 2-stage rocket consisting of the core stage, built by Boeing, utilizing those 4 repurposed space shuttle engines, or SSMEs, which are powered by liquid hydrogen, liquid oxygen, or Hydrolox. The core stage is assisted by 2 5-segment solid rocket boosters, again repurposed from the shuttle program. The core stage and SRBs provide thrust for the first stage of flight. The second stage, for the first few flights at least, is called the ICPS, or Interim Cryogenic Propulsion Stage. It's basically the same second stage as the Delta IV rocket, stretched to include more propellant and rated for human flight. Sitting on top of the SLS stack is the Orion multipurpose crew vehicle, made up of the crew vehicle itself, built by Lockheed Martin, and the European service module, built by Airbus Defence and Space. SLS is hoping to make its debut flight later this year. The two solid rocket boosters have been stacked in the vehicle assembly building at Kennedy Space Center in Florida, and the core stage has completed its green run test firing and just arrived at Kennedy just over a week ago. The final assembly can now begin. Orion is a partially reusable spacecraft. Before re-entry, the service module detaches and will eventually burn up on re-entry. The crew vehicle will then descend under parachutes and splash down in the ocean, eventually being refurbished and flown again. The capsule is capable of carrying 6 humans to beyond low Earth orbit, lasting up to 21 days in free flight or up to 6 months when docked to either Gateway or the International Space Station. At the moment, Orion can only fly on SLS, but that may change in the future if the cost to launch SLS doesn't drop. Since Orion was initially part of the Constellation program, its design started in 2006 before being repurposed in 2010 and again in 2017 for Artemis. Total cost from 2006 until today is about $18.7 billion. Building on the success of the commercial resupply contracts to deliver cargo to the International Space Station at a substantial cost savings, NASA came up with the Gateway Logistics Services contract to bring equipment and cargo to lunar orbit, the same way we service the space station now. In 2020, the contract was awarded to SpaceX to develop a larger version of the Dragon spacecraft, which is currently serving the space station. Dragon XL can carry more than 11,000 pounds of cargo to the Gateway outpost, launching on SpaceX's own Falcon Heavy rocket. Falcon Heavy was also contracted to carry the first 2 components of Gateway to lunar orbit, again, reaping the benefits of commercially available launch services. The Human Lander System, or HLS, is another key component of Artemis, tasked with bringing humans back and forth from Gateway to the lunar surface. NASA solicited designs from commercial partners to develop the HLS, initially selecting 3 proposals in April of 2020. The selected proposals included SpaceX's Lunar Starship, the Human Landing System from Dynetics, and the integrated lander vehicle from the national team, comprised of Blue Origin, Lockheed Martin, and Northrop Grumman. In April of 2021, NASA selected the Lunar Starship for the final development. Dynetics and the national team filed legal challenges with the Government Accountability Office, which was basically expected. Aerospace companies tend to be very competitive when it comes to billion-dollar contracts. So while the GAO investigates, NASA had to suspend the Starship HLS contract until the legal challenges are resolved. Fortunately, SpaceX has bigger plans for the Starship architecture than just the Human Landing System. In our January Second Saturday Stars event, I spoke more in depth about the evolution of Starship itself. To summarize, Starship is a first-of-its-kind, fully reusable super heavy lift rocket. To date, SpaceX has flown the only partially reusable rocket with the Falcon 9 and Falcon Heavy. With Falcon, it's only partially reusable because the first stage can land back on Earth for refurbishment and reuse, while the second stage is expendable. It burns up in the atmosphere after completing its mission. With Starship, the entire vehicle is both the second stage and the spacecraft, completely reusable, launching on the Super Heavy booster for the first stage. The unique re-entry and landing profile make it capable of landing vertically in places where no landing pads or runways exist, like on the lunar surface or Mars. It belly flops and falls through the air horizontally like a skydiver, using winglets for attitude control, letting its engines to pitch back vertical for a soft landing. Key to the lunar and Mars ambitions is the capability to refuel on orbit. How much payload any rocket can carry beyond Earth orbit is determined by how much propellant it can hold onto after arriving in orbit. Refueling in space dramatically increases how much stuff can be brought beyond Earth orbit. While SpaceX cannot continue with Lunar Starship development specifically until the legal challenges to the HLS are settled, they can still move ahead with cargo, crew, and tanker versions, along with the Super Heavy booster. Since all share a common architecture, SpaceX continues to make progress with their rapid prototyping and test programs. To that point, just 2 days ago, SpaceX launched the SN15 prototype of Starship, which flew up to 10 kilometers in altitude and successfully landed for the first time. The Super Heavy booster sections are being assembled now, along with the orbital launch mount and integration tower, to stack Starship on top of Super Heavy. The hope is to make the first orbital flights of Starship by late July or August of this year, after only being in serious development for only about 3 years. 2024 is only 2.5 years away, and there's still a lot to do. Of course, SLS must complete assembly and its maiden test flight without crew on board. First mission will be called Artemis 1. It will demonstrate the capabilities of SLS and the Orion spacecraft on a 26-day mission around the moon. The hardware for Artemis 2 will need to be assembled and tested in time for a 10-day crewed mission around the moon, targeting August 2023 for launch. The first 2 core components of Gateway will be launched, scheduled for May 2024. Then the human landing system will launch sometime in the middle of 2024 to rendezvous with Gateway, followed by Artemis 3 in October 2024. This will be a month-long visit to Gateway, with likely excursions to the lunar surface via HLS, returning humans to the moon for the first time since 1972. Along the way, there are going to be various support missions to send landers and equipment ahead of crew. The goal of Artemis is to be sustainable long-term, so the plan is to send up most of the needed support equipment ahead of time. These supporting pieces are being developed by private industry, further leveraging the commercial partnerships to reduce cost. So we're finally heading back to the moon, more than 50 years since humans last set foot on the surface. Whether we can do it by 2024 remains to be seen, but we are moving in the right direction. And this time, with the involvement of private industry and international partners, the future looks pretty bright for human exploration beyond low Earth orbit. Thank you. And please join us on June 12th for our next Second Saturday Stars.
Thank you, Mark. Thank you, Bill. Those were both excellent presentations.
I have one question for Bill. Amy asks, what's the process for extracting oxygen from CO2?
They're using electrochemical process, which means that they're using high temperature heating to disassociate the molecules, which is kind of a challenge because you have to insulate that MOXIE unit from the rest of the rover due to the high temperatures. But it's like a reverse fuel cell. They're basically just applying a lot of power to separate the CO2 molecules.
And Jane Lambert says, this is my favorite part. Thanks, Bill, referring to your presentation.
That was great. I would open my presentation again, but it seems to be frozen. So this is the best I can do. If anybody has been by the observatory or has not been by the observatory, we are not open yet, but we continue to develop the gardens. And there's a beautiful pollinator garden on the north side of the building, but we're also revamping the gardens on the south side too. So, stop by and take a look sometime.
Johnston Space Program asks, what will be the next Starship prototype to fly? That's a tough question. It's SN16 is currently stacked in Boca Chica and almost ready to roll out to the launch pad. But they might also opt to launch SN15 again, depending on whether they've got all the data they put from SN15 or whether there's refurbishment that needs to happen. So they're still analyzing all the data from SN15 flight now, going through 3 days ago. And I expect within the next week or so, we'll know whether we'll see SN15 fly again or whether the next Starship prototype will be SN16. I know they are very, very close to being happy with Starship as it is. So they may, after SN15 or 16 flies again, jump right to SN20, which will be their first orbital attempt with a super heavy booster under it. So it's going to be an exciting month or two for watching the Starship development.
Anything else?
No other questions yet, but we'll give it another minute or so.
Yeah. Or if anybody thinks up questions later on, they can always send us an email to mccarthy.observatory@gmail.com. If you're not on our mailing list right now and you'd like to be for future announcements, send an email to that same address, mccarthy.observatory@gmail.com, and we'll add you to our contact list, keep you up to date on what's going on and what our plans are for reopening.
Okay, next question is, where will NASA be flying their helicopter next on Mars?
From what I understand, the helicopter is going to be coordinated with the rover. So depending upon where the rover plans to drive to next, the helicopter can be used as a scout, because it didn't go back to Wright Brothers Field. It flew on beyond. So it's waiting for its next assignment. It could do some aerial scouting. Yesterday, it went to its normal elevation, and then it went up to about 33 feet and took some color images of the surrounding area, which will be analyzed. If there's something interesting, maybe the rover might go investigate. So they're really going to play off the helicopter and the rover. They don't want the rover to have to suspend operations waiting for the helicopter. They don't want the helicopter to interfere with rover operation. So it's going to be a work in progress. But the good news is that the helicopter could be flying until maybe late August if it could be useful.
I have a follow-up to that, Bill. Do they have any idea what the life expectancy of the helicopter is going to end up being? I know one of the biggest components is probably going to be keeping that battery warm, and I can't imagine it's a tiny solar panel.
The solar panel on top of the helicopter, which provides all the power, has performed, I guess, greater than expectations. It's getting some dust accumulation, but it still is putting out more than enough power to keep the helicopter warm at night and to fly during the day. So, originally this was a 30-day mission, and they were going to put it down at that point. but right now, power doesn't seem to be a limiting factor. Tested in a vacuum chamber at JPL. They spin about 5 times faster than the conventional helicopter on Earth. They also keep the weight down. On Earth, a helicopter weighs 38% of that on Mars. And also, Mars's gravity is fairly low compared to Earth. So all those factors feed into the ability of flight, even a rarefied atmosphere as Mars.
All right, I think that'll wrap us up now.
All right. Well, thank you, everyone. Thank you for joining us. And Mark and Bill, thank you both for some excellent presentations. And we will hopefully see everyone next month, June 12th, for our next second Saturday Stars program. Good night.